Section we learned about the product property of radicals, and we discovered how to use the product property of radicals to simplify radicals that have a radicand that is a non-perfect square. And just as a reminder, the radicand is the value underneath the radical symbol. So in this case, the radicand is the 50. And to simplify the square root of 50, it doesn't have a perfect square root, so we will need to use the product property to separate out the perfect squares and the non-perfect squares. So what is the perfect square factor in 50?
25 and 2.
25 and 2, good. 25 and 2, where 25 is my square and 2 is my not square. So we're going to take the square root of 25, which is 5, and that takes care of the radical symbol. And then we still have the square root of 2. This is a multiplication function. It's 5 times the square root of 2 because we used a product property to pull it out, which means that's also multiplication. Make sense?
Yes.
Okay. So that was a review of the last section. And then, of course, we went into the ones with the algebra expressions and the polynomials and stuff. But if we just look right here, if the square root of 50 equals the square root of 25 times the square root of 2, then by reversing this, we can say that the square root of 2 times the square root of 25 equals the square root of 50. Make sense? Okay, so what that shows us is that if we have one radical times another radical, we can combine them together by multiplying the radicands together to form one combined radical. So let me show you an example. We'll start pretty simple. If you have the square root of 2 times the square root of x, then they just combine to make the square root of 2 times x, or 2x. Okay, and that's as basic as it gets pretty much. Now, the reason that's useful is because sometimes once you multiply them together, like we can start out with two irrational values, and when we multiply them together, we might get a radicand that has some perfect square factors where we could actually rationalize part of the factors and simplify the expression farther. Okay? Let me see if I can find an example here. If I have the square root of 3 times the square root of 18. Okay, so right now, the 3 does not have a square root, and 18 does not have a square root. Now, you might recognize that we could simplify 18, but let's go ahead and combine them together first. Okay, so what's 3 times 18?
54.
54. And what is our perfect square factor in 54?
9.
9.
And 5.
9 times 6.
6.
9 times 6. Yeah.
Sorry, excuse me.
Okay, and then we take the square root of 9. 6 is only factors of 2 and 3, neither one of which is a perfect square, so it remains in the radical. Okay, so see, we combined, we resimplified. And that's really what this section is about. You multiply and then you resimplify by separating again. It's kind of like combining two things and then separating them in a different manner. That will help us. Because in the first one, we would have ended up with two radical symbols, and it's really, you can go about it either way. We could have gone ahead and said, okay, well, 18 is 9 times 2, right? So then we could take the square root of the 9, which is 3. We're left with the square root of 3 times the square root of 2. Multiply those together, and we end up at the exact same point. See how you can go either way? Okay. The thing is, with the numbers, it's really easy to see that you can go either way. When we start doing the expressions with the variables and binomials and things, it's not going to be as easy to visualize that. So for the purposes of this chapter, let's practice the first way, where you multiply to combine and then resimplify from there. Fair enough?
Sounds good.
Okay. Moving on. Let's do a bigger one. Let's see. Square root of 12x to the third y squared times the square root of 8xy. xy. All right? So we want to multiply first. So what is my new radicand going to be when I multiply everything together?
That would be
Numbers first.
94.
12 times 8?
No.
Try again.
96.
96 is probably a better answer because it's the right one. So,
Yeah.
Okay.
I hope so.
And then
X
X
to the
four,
fourth, Y to the
Okay.
third.
Y to the third.
Yeah.
Okay, there we go. Now we want to resimplify.
Yes.
So, how should I separate this?
So
You
36.
do-
Okay, if we're not sure, let me show you what we can do.
16.
Ooh, 6 and 16, nice. Let me show you how we can get there.
You cheated.
Okay.
Yeah.
do 12 and 8 share any factors?
It does.
What factor do they share? What's their GCF?
4.
It's 4. So you can think of 12 as 3 times 4, and you can think of 8 as 2 times 4, right?
Yeah.
Now, if we put the 4 and the 4 together, that gives us the perfect square of 16, right?
6.
So 12 times 8, we take the 4 and the 4 and combine them. We take the 3 and the 2 and combine them. 12 times 8 is the same thing as 16 times 6. See how you can do that? Okay, so let's, you can always use factoring to find your perfect squares. So we're going to say the square root of 16, and the other one's going to have a 6. And then what about my variables?
16x squared.
Y squared.
Y squared.
No, not y.
Right in third.
Oh, God.
Not y the letter. I'm asking you why would you put x
because-
squared?
Because you're taking it and, oh wait, no, I didn't. So x to the 4th.
X to the 4th. There we go. And y in this one?
No,
No,
the
Y.
next one.
The other
Y,
one.
and then times 6y squared.
6y.
No, I'm sorry. Squared in the
Cute.
first
You
one.
guys are not on top of it today.
Y is squared in the first one. And then 6y.
There you go. Now we're there. Okay. So
You know where it's
you were about to say
I
it?
said that
After
first.
Carson's.
You were gonna say it, Karen. So don't even say
Okay.
it.
So let's take. How about we let Cameron do it then, since he's really
Okay,
confident. Okay.
So 6. So we have 4x squared, and then y.
Oh.
Yeah. And then what's
And
left
then
under here?
Squared, and it's squared 6y.
Square root.
Yeah, the square root thing.
Come
Yep.
on, Cameron.
Yeah.
The
Come on,
square
Cameron.
root.
Yeah, okay, right. Come on, Karen.
Okay.
I
And
got the
there's
squared root.
yeah, absolutely. Okay. You gonna do a couple more?
Yeah.
I would like one more.
One more. Okay.
I need that.
Precise.
You might want another one after you see this one. Okay, I'm just gonna jump in and go for the hardest one I can find.
What? No.
Guys,
Of course, the ones that look the most complicated usually are not the actually most complicated ones.
So
B squared plus 4b.
Oh, times.
And yes, that does say to the 32nd power.
Oh my
Okay.
gosh, that's a lot of powers.
So where should we start? What's the first thing you think we should do?
I think
Factor. Who said that? Ashley?
Oh.
Yes.
Yes, factor. Absolutely. No, she's right. Let's factor this a squared plus 4ab plus 4b squared. Do you recognize that?
Yes.
What is it?
It's
that is wait.
A
Oh.
That is a
plus.
no, wait, it's a
Two.
trinomial square.
It is a trinomial square. Good job. Okay, you'll see a lot of those in this unit. So, what is it?
It
It's
is
A plus 4b plus
A plus something. A2.
What?
A and a 2, yeah.
B.
A plus 2 and then b plus 2.
Yes, that's what it said.
No, that won't work.
No, it's a b squared.
Okay.
A plus
For
B squared.
guys, for a trinomial square, the first term is the square root of the a, and the second term is the square root of this one.
So A plus 2B.
A plus 2b,
Yeah. A plus 2B.
and that's squared because it's a trinomial square, right? Okay. So now, see, it's really not as complicated as we thought.
Wait,
So
but
now-
there's 3 A's
No, there's not.
Oh my
in the
God.
problem.
What?
No, this one's gone. We factored it.
Then you can combine my terms.
We're multiplying. We need to multiply them together first. So we have an a plus 2b to the second power
Yes.
and an a plus 2b to the 32nd power, and we're
So that would
multiplying.
be a plus 2b to the 34th power.
Absolutely.
Yeah.
A plus 2b to the 34th power.
Let's
So
do it.
what would the square root of that be?
My painting.
That's where what? So then it'd be A plus 2B to the 32nd.
Fourth.
Then
Can you
30,
combine them?
the square root of
Because
3
you cross out
and
2.
also 4.
Mm. Okay, let's review how to do these. Hold on, let me get another sheet of paper. All right, if I have the square root of x squared, what's the answer?
X.
X.
X. If I have the square root of x to the 4th, what's the answer?
X squared.
Okay, and the square root of x to the 10th? Oh,
is
that's not an x. X to the 10th?
X
I'm about to say
X to the 5th.
Yeah.
Okay, so what's the square root of x to the 34th?
Oh, 17, 17.
Okay, x to the 17th. So what are we doing with the exponents when we take the square
A
root?
plus 2b
To the
to the 17th.
No, answer my question first though. What are we doing to the exponents when we take the square
We're
root?
dividing them in half.
We're cutting them in half. So let's go back to this. So to take this square root,
A plus
So it would be
2b to the
A plus
17th.
2b to the 17th.
there you go. A plus 2b to the 17th power is your answer. Right? So, as,
Yeah.
like I said, as complicated as it, yeah, that was a little much. As complicated as it looks, it really wasn't that hard of a problem. You just had to recognize that you needed to factor. Right?
That's pretty easy.
Yep.
Those
Now we have to
30s.
divide.
Now let's do divide.
Stop.
Let's do one that's a little bit harder.
Oh,
Okay.
Lord.
Okay, what, you might, and actually, let's review this real quick. Okay, so I have x to the 3rd times x to the 5th. What's my answer?
X to the A.
That would be x to the number 8.
8. So when we multiply the exponents, what do we do with the powers?
Adding the,
Add-
We add them.
20
Okay,
times
just
the
to make sure we
powers.
remember that, because you're going to need to remember that here. Wow, that red dot went all the way through. Look at that.
Oh my god.
Still
Okay,
there.
I know, and it's not even a permanent marker. Okay, let's see. Square root of x to the 2n power, okay, times, yep, I know this is a little bit new, but we'll be able to handle it.
It's the same concept. It's not.
Okay. Times, mm-hmm, okay, to the n plus 1. So, just you know how to multiply exponents, right?
Yes.
Okay, so we need to multiply the x terms together to get our, because remember, we're combining all these using the product rule for,
Would you
Radicals.
combine the s n plus 1 into
well, let's focus on the
Or
x's
never
for right now. We have x to the 2n and x to the 3rd, right?
You can't combine that. Can you?
No, let's look back here. How did we multiply these?
You add it.
We added what?
X,
5n.
X 5n.
No.
Is
X,
2n plus
2n
3? Okay, I was going to say, is 2n plus 3 the same thing as 5n? It's not, right?
No.
So we have to keep them as separate terms because they're different types of terms. So it actually is x to the 2n plus 3 power. Okay? And then what about my y?
That would be y for n. Because you can combine it.
You
Because,
can combine that, but what about the other one?
There's not another y.
There's a 1 right there.
It would just
You
be
can do
just
y 3 and square root plus 1.
4
We're-
n. It would be 4 n.
4 and 4 and 4
Four
and 4.
plus
Sorry.
It's
Nice
four.
trying to be
y
smart,
to the
smart
3n times y to the n plus 1. If we're adding the powers, then our new power is going to be 3n plus n plus 1.
Yeah.
Which is
know the one
You wanna
was.
know
Four-
I didn't know the one was connected to the y. I'm
4.
sorry.
Yeah, that's all up in the exponent. That's all the power. That whole thing is the power. So 4n plus 1. Okay?
And that
Yeah?
Is not your
is
answer.
not the answer because now we can do y 2n plus 1
What?
Okay. So
times the square root.
here's where we have to get kind of a higher level thinking about this, okay? I don't even know if that's not an adjective, but that's okay. If we have the square root of a variable with an even exponent, we know that we can just cut it in half,
Yes.
right? Now, if we have the square root of a variable with an odd exponent, what did we learn in the last section that we need to do?
X to the 5 and X to the 6.
No.
Oh no. Oh well.
Yes.
Try to find.
No. How many do we take off of it? This was
Oh,
Wednesday's.
it's X to the 10th and then X to the.
Yes, we always just subtract 1 to make it even, right? So we always subtract 1 from an odd exponent to make it into an even exponent so that we can take it, so we can simplify the square root.
So now it's
Right?
it's a trick.
So knowing that, remember that's the process, is we always subtract 1 from an odd exponent in order to give us a perfect square that we can take the square root of. Yes?
Yes.
Okay, so let's look up here. We need to know, is this going to be even or odd? 2n plus 3. Is that considered an even or an odd exponent?
That's
an
considered an
Odd 'cause the
odd.
last-
Because, good, yes, it's odd. Because when we multiply something by 2, that's an even number, right?
Yes.
But if we add 3 or any odd number to an even number, we get an odd number. So this whole thing is actually going to be an odd value. So use the exact same rule, okay? I need to subtract 1 from this in order to separate it out where something I can take the square root of and something I can't take the square root of. Just stick with me, okay? So if I'm going to subtract 1 from this exponent, what would my new exponent be?
2n plus 2.
Good. Good job, Cameron. 2n plus 2. And then I have my x and that 1 that I subtracted. You see that?
I do see that.
Okay, so now we know that this is an even value. So we can cut it in half to take the square root of it. We need to do the same thing with y. Because is this even or odd?
It's odd.
It's going to be odd. Because if you multiply something by 4, you get an even number. Because that's an even, it's a multiple of 2. So if I multiply any n, anything that it could be, by 4, that'll be even. And then I add 1, that makes it odd. So to give me an even exponent, I need to subtract 1. So if I subtract 1 from this power, what will my new power be?
Y to the 4n.
Yes. Y to the 4n. And then over here, what do I have?
The
Y.
plus 1.
Just y, or that 1 that I took off. Okay? Everyone with me still?
Totally.
Yeah.
Yes.
Okay.
And then you would do x to 1n
Well, all of that. So x.
plus 1.
X to the, so
No, he's right. He
X and plus
okay,
y.
to
And
take
then
the square
y
root
to
of an
y.
even exponent, we divide the exponent in half. So if I have, I'm going to do this over here. Let me do it in a different color. If I have 2n plus 2 divided in half, you guys know how to do that, right?
n plus 1.
Distribute the denominator.
Yes.
So what do we have?
Oh,
So
which
x
sounds-
n plus 1.
n plus 1.
plus 1, and then there's a y to
And then
n.
y to
And a
n.
y to, perfect. Nice job. And then I
then
still
you
have
do
my
y.
x, y under here, and we're done. You guys did it.
Okay, cool.
See?
Now we have to-
That one actually was hard.
Well,
Right.
I knew that it was the same concept. I just had to learn how to.
I just
It really makes you, when you have those exponents that aren't just numbers, it really makes you think about why we do what we do and how we do what we do in order to process it. But I think that's a good exercise, is
Okay.
to do this once in a while. Okay, so is the multiplication thing, we good? That makes sense?
Yeah.
Totally.
Okay, let's move on to the division side of it. All right, this is going to be section 11.5, which is dividing radical expressions. Okay. So just like we had a product property of radicals, we also have a division property of radicals. Pretty much the division property of radicals says that if you have a radical of a division expression, or a rational expression, then you can separate it to two radicals in a bigger, like a different rational expression. I'm not explaining this well. You see, just look. It makes sense, right? You take the fraction and you just divide it out so that there's one radical up top and one radical down bottom. Having trouble with my words and vocabulary this morning. So that's the general rule. That's the division property for radicals. Okay? And so to simplify an expression like this one, we can say, okay, well, that's the square root of 25 over the square root of 9, right? Which is just 5 over 3. Absolutely. That's all. It's real simple. It's pretty straightforward. And likewise, we could also go from, let's see, here, okay? We could combine them. What's 1,000 divided by 10?
That would
Be 100.
Do the division first, and then take the square root. So it's just like with the multiplication, there were 2 ways to go about it. There's 2 ways to go about these problems. You need to find the one that's going to help you simplify the problem. In this case, it was much easier to take the square root of 25 and take the square root of 9 before we tried to worry about dividing 25 divided by 9, right?
Yes,
Down here, it was better to go ahead and do the division, 1,000 divided by 10, and then take the square root. The rule is what allows us to do that. It allows us to combine and separate them so that we can change the order in which we evaluate the problem. Yeah? You guys are really quiet.
No,
Are we
get
good?
it, I get it.
Okay.
We get
We're
As long
just-
as long as Carson gets it, then we're fine. He'll explain it to everybody else. All right. So let's just, yeah. Here's an example. We have 18 over 32. Okay? Now, are either of those perfect squares?
No.
Are they related to any perfect squares?
Yeah.
Okay. Like what?
Like 9 and 2.
Okay.
Oh, 9 and 2, 9 and 4. Okay.
And what about 32?
And then 9 and 4.
And then 9 and 4.
Oh, no.
No?
That's 36. That's 36.
How about 8 and 4?
8 and 4. That's
Does that help us?
Yes.
Yes.
Is there a better way we can do it?
Actually, wait.
I think there's a better
we
way.
could do 16
Yeah.
and 2.
Let's do 16 and 2. I think that's better.
You have it.
Mm-hmm. All right, now,
Cancel out the 2s, right?
cancel out the
Yeah.
2's. There you go. That's why that helped us. Now,
Okay.
what we have
3
is
over 4.
perfect squares, which we could separate. You do not have to write this step, guys. You can do this step in your head. That step
Okay.
right there,
I
okay?
was like, oh.
Yeah, no, that step right there you can do in your head. I'm just showing you for purposes of this lesson.
3 over.
There's your answer.
Whoa.
Mhm.
Now, do we have one?
I'm such a smart
You want one with
girl.
variables? Is that what you're asking?
Do it.
I love it when you guys ask for harder problems.
Let's do it.
I want to do the hardest problem.
You should
Well,
let
let's
us
do
one
a
on the
medium
board.
problem before we do the hardest problem, okay?
No,
You
hardest
should
problem.
let us try one on the board.
Do it with
Okay.
exponents.
Yeah, but then they wouldn't be able to see it. Lindsay. Okay.
Who said that? She can maybe aim it upwards. No, okay. that one works way too
This one's not hard. Hold on.
far. Okay,
Actually, you know what? Okay, there we go.
there you go.
This one's not hard either, but it has a variable in it.
That's fine.
Okay. Oh, you can't see it.
Whoa.
Square root of a cubed over the square root of 8.
So that would be a squared and a.
It would be what?
What?
It would a
He separated.
Oh,
to the
yeah, he
second
separated.
power
Oh, yes.
and
A
Okay,
squared.
So he's
and then
simplifying it by saying a squared and a,
And
and
then
then-
there would be 2 and 4.
Or 2.
4 and 2. Put your perfect
Okay,
squares first, okay?
4.
Yeah, Carson.
4 and 2. So that simplifies to,
So A to the, and then square root A,
mm-hmm.
and then 2 square root 2.
Okay. And
Yeah.
that's as far as we can go with simplifying the radical parts. Okay, now I'm going to teach you the next thing that's in this unit, and it's very, very important, and you will hear it all the time as you get into higher math, okay? It's called rationalizing the denominator. What that means is that for a problem to be simplified, we cannot have a radical sign in the denominator of a fraction or of a rational expression, okay? Just, that's the rule, the basic rule. We have to get that out from under there, right? So the way that we do that is, if you remember, like the square root of x times the square root of x equals just x, right?
Yeah.
So by multiplying a radical by itself, we are effectively removing the radical sign. Yeah?
Yeah.
So what would I multiply the square root of 2 by to get rid of the radical sign?
2.
Not just 2,
Square root.
the square root of 2. So I need to multiply that by the square root of 2. Now,
Shut up.
this is a fraction, so is there something that I can do that will actually allow me to do this without changing the value of this fraction?
Ooh, put the square root of 2 at the top.
Good. Multiply it by, yeah, something over itself is 1, so that way I'm not changing the value.
That's good enough.
So by doing this multiplication, now I have 2 times the square root of 2 times the square root of 2. What does this simplify to?
That equals 0.
2.
Not 0. 2.
2.
So 2 times 2 is 4. Good.
Eli.
So now my denominator is rationalized. Do you see that?
Yes.
So then up top, yeah, what'd you say?
2A.
2a. Where at?
On the top. Or wait.
Inside or outside the radical?
Inside.
Inside the radical.
Or Cameron.
Oh.
And am I done?
I was telling you.
Oh,
Okay,
wait.
I was telling you.
Yeah, there's an A on the outside.
Yeah.
There you go. Okay, that is rationalizing the denominator, guys.
Right.
You cannot give me an answer that still has a radical symbol in the denominator. You understand that?
We can.
So for every single problem where there's a rational expression involved, where there's a fraction, you have to, before you write down your final answer, you have to rationalize the denominator. You always do that by multiplying whatever radical is in the denominator, multiply it by itself, and do the same thing to the numerator so that you keep it equivalent. Yes?
Why did we put the 2 at the top?
This 2 came from here. Remember you told me to multiply by square root of 2 over itself? So that 2 times that A gave us the 2A.
Yeah.
Make sense?
Yes,
Okay, I'll show you another one. We have some time. I think we have about 5 minutes left.
Is this on this IXL?
IXL is just multiplication. You won't have any denominators.
Okay, cool, awesome.
Okay. There is the very next section in IXL, if you want to practice this, I think it's E.4, should be the dividing. And or you can just search rationalizing denominators, and there should be a whole section on just rationalizing denominators. Okay. All right. Let's see.
Let's do a hard one.
A hard one?
Yeah, the hardest one.
Please.
Let's do it.
Hold on, I'm looking.
I'm ready.
I'm
He's like,
looking.
do it now.
My body is ready.
Okay.
Okay.
This one's not, I mean, it's not super hard, but it gives us practice on both concepts, okay? So, where should we start?
We should start at the 5 and the 6.
What?
It looks like they probably have some common factors, so if we combine them, we might be able to
So
reduce.
So
4.
9 and
8 and
No,
7.
no, there's a higher one, I'm pretty sure.
9 and 6.
We're all saying stuff
Nine
at
and
the
6.
same time.
9 and, that's not 9 times 6. That's 9 times 6
Oh,
is 54.
Gosh dang it.
It's,
That's
8 and
54.
7, right?
it's 8 times 7, but neither of those are perfect squares. The biggest perfect square in here is a 4.
Well,
4.
it's 8, well, I'll say 8 times 7 because then.
4 times 14.
14. Yeah, that's it.
And then 4 times 10.
And
then
4
you
times
cancel
10.
And then you cancel the 4s. I said that before it came.
Okay.
Yeah?
And then
Cross
the
out the
square
four.
Okay,
root
so that
of
crosses out, but these still have common factors, right?
Yeah, you have
7 and
You
2.
have 2.
Oh,
Okay.
wait, no.
7 and 2 and 5 and 2.
7 and 2 and 5 and 2, yeah. And then you cross out the 2s.
Okay.
And 7
And you can do that because remember, the 2 separate radicals is the same as just a single radical,
Yeah, so
right?
square root of 7 over 5.
Yeah. So square root of 7, well, you're saying square root of 7 over 5?
Yes, ma'am.
Okay, but we need to rationalize the denominator. We're not done. You can't leave a fraction under the denominator, or under the radical, and you can't leave a radical in the denominator. So neither one of these is simplified.
So.
What do we multiply by to rationalize?
We do the 5.
Square root of
We do
5.
the square
Over
root
the
of
square root
5,
of 5.
and then the square root of 5 at the top.
Okay, and then you
And
have
then you'd
30.
have
35 over 20.
35 over what?
35 over 5.
Like that?
Yeah.
Oh, because you can.
No.
You're missing something.
35
Square
over
root of
25.
There you go. The square root up top didn't go away.
Oh.
Okay? The square root up top didn't go away because it's the square root of 35 over the square root of 25, which simplifies to 5.
Yeah.
See how that happens?
Yeah.
Okay? The square root does not automatically go away when you multiply 2 radicals together. It's only if that makes a perfect square. Then you can remove the square root. There's an unseen step right here that we don't write down, which takes us to the square root of 25. That's why when we multiply a radical by itself, the radical disappears. Because what we're actually doing is we're forming a perfect square. Yeah?
Yes.
Okay. We're going to stop there. Finish your IXL for homework, okay?